Hello students, welcome you all to the video lecture on signals and system. We are going to draw the different signal for the given x of t. So x of t, it is a continuous time signal. Why? Because we have the values for all the values of t, that is from 0 to 1, all the decimal point values also we have amplitude, hence it is a continuous time signal. So for this signal we are going to find out 2x of t, 0.5 x of t, x of 2t, x of 0.5 t and x of minus t as well as x of t minus 2. Okay. So for this, first of all we have to know few operations on the continuous time signal. Okay. So one is your amplitude scaling. So this is one operation, amplitude scaling, that is your x of t will be multiplied, the amplitude will be multiplied by some other constant like this 2.5 like this. Okay. So such operation is nothing but amplitude scaling. And next is nothing but time scaling. So here time scaling means the given functional value of t, right, x of t, this t will be multiplied by some value or divided by some value. Okay. So like that if we have, then it is said to be a time scaling operation. If the whole x of t is multiplied by some constant, it is amplitude scaling. If the functional value t is multiplied by some value, then it is said to be a time scaling operation. Okay. And then next is your time reversal. Time reversal means the functional value t will be reversed with the amplitude, that is t will become minus t. This operation is nothing but time reversal. Next is nothing but time shifting. So time shifting means the given signal will be shifted by some constant value. Okay, that is t either plus some value or minus some value you will get. That is nothing but time shifting operation. Okay. So this is amplitude scaling, again this is amplitude scaling, this is t is multiplied by some value, so it is time scaling, again t is multiplied by some value, it is time scaling again. Here t is multiplied by minus 1, that is t is reversed, so it is time reversal. Here t is subtracted with some constant value, hence it is time shifting. Okay. So these are all the operations. So first we have determined all those things. Okay. So let me draw one signal. So the first signal we need to draw is 2 into x of t. Okay. Whenever it is amplitude scaling, just multiply your amplitude by the given constant value. That's all. You can find out the output. Okay. So let me draw here itself. So this is the given x of t. So the amplitude is multiplied by 2. So 1 into 2 will become 2, 2 into 2 will become 4. Okay. This time value remains same as it is. So time value whatever in the signal, original signal, write as it is. Okay. So again draw the signal as how you are having here. So instead of drawing at 1, I have to draw at 2. Instead of drawing at 2, I have to draw at 4. Okay. Similarly, complete the other axis of t. So this is your x of t into some constant amplitude, that is 2. Okay. So this is the first signal. Just write all the values of t as it is, multiply your amplitude by 2. This is your amplitude scaling operation. Similarly, find out the second signal. Okay. So here x of t, again it is multiplied by constant value 0.5. Okay. So 1 into 0.5 will become 0.5, 2 into 0.5 will become 1. So constant t value you write as it is without any change and draw the signal how it looks like. Just draw the signal how it looks like in the original signal. Okay. So now x of t is multiplied by 0.5. Okay. So when you see the signal, now the signal amplitude becomes high. Okay, so hence this type of signal is called as amplitude magnified signal, because your amplitude has been increased. Okay, so here this signal is nothing but amplitude attenuated signal. Why? Because the amplitude has been decreased. Okay, so this is your amplitude scaling operation. So next let me see the time scaling operation. So just draw the original signal as it is, so that it will be easy for you. This is my original signal. Now I have to draw the third signal, that is x of 2t. Okay, so t is multiplied by some constant. So here we have to see, we have to consider the functional value as that of modulus of a into t. Okay, that is either it may be negative value or positive value, no need to bother about that. Okay, so this modulus of a value, if it is greater than 1, we will be getting time compressed signal, and if modulus of a lesser than 1, we will be getting time expanded signal. Okay, so this thing you have to notice. So again here modulus of at, okay, modulus of at is what here? Modulus of 2 into t. Anyway, modulus of 2 into t is what? 2t. Okay, so this 2t value we have to equate to 1 always. Okay, so once you have equated, find out the t value. T is equal to 1 by 2. This t equal to 1 by 2, always I have to multiply with each and every instance of t. Okay, so from the name itself, it is called time scaling operation. So time scaling means we have to modify only the t values, time. We should not touch the amplitude. Okay, so only t will be modified. So if it is a time scaling operation, whatever you have here, just take the modulus of that value. Okay, and then equate the value to 1, find out the t value, and multiply this value with each and every instance of t, so that you will get the signal. So what happens? 0 into 1 by 2 is 0, 1 into 1 by 2 is 1 by 2, 2 into 1 by 2 will become 1, 3 into 1 by 2 will become 3 by 2. Okay, so draw the signal as it is, how it appears in the original signal. Amplitude there is no change, so write as 1 and 2. Okay, so x of t will become now what? X of 2t. Okay, so it is x of 2t. And then coming to the fourth signal, that is x of 0.5t. X of 0.5t. Okay, so as usual, modulus of a t is equal to modulus of 0.5 t. Anyway, that value is what? 0.5 t, which is equal to 1. So t equal to 1 by 0.5. 1 by 0.5 means it is 2. Okay, so now with each and every instance of original signal, okay, we should not multiply with the signal what we have obtained previously. Okay, so here t is equal to 2 now. Okay, this 2 I have to multiply with each and every instance of t appeared in the x of t. Okay, so what happens? 0 into 2 becomes 0, 1 into 2 will become 2, 2 into 2 will become 4, 3 into 2 will become 6. Amplitude remains same, there is no change, and draw the signal as it is, how it looks like in the original signal. So it is x of 0.5 t. Okay, so you can see the signal. Here the range is 0 to 3. Now it has been increased. Okay, that is what I have said. Whenever modulus of a, what is modulus of a? 0.5. 0.5 is lesser than 1. You will get what? Time expanded signal. Okay, so here I got time expanded signal. Actually the original signal range is 0 to 3. Now I have obtained 0 to 6. Hence it is called as time expanded signal. Similarly here the original signal range is 0 to 3. Now it has been compressed to 0 to 3 by 2. Okay. So whenever modulus of A is greater than 2, it will be getting time compressed signal. So this signal is time compressed signal. Okay. So both the operations comes under time scaling. So we have completed the time scaling operation. Okay. So next we will move on to the next two problems. Again the original signal we require. This is my original signal. So take the original signal as it is. Now I have to draw the fifth problem, that is x of minus t. So x of minus t is nothing but reversal signal. Okay, just reversal of a signal you have to draw. Reversal is nothing but the mirror image. Whatever you have in the right side, draw in the left side. Whatever you have in the left side, just draw in the right side. Okay. So 0 will be there as it is. Again the operation is what? Time reversal. Why? Because t only has changed. So t has been changed as minus t. Hence the operation is called time reversal. Since you are reversing the time, there will not be any change in the amplitude part, only the time changes. So 0 will become 0 because minus 0 is 0. Okay. 1 will become minus 1, 2 will become minus 2, 3 will become minus 3. Okay. So whatever you have in the right side, just draw in the left side. Okay. As how you have in the right side, just you have to draw in the left side. There is no change in the amplitude. So 1 and 2 will remain as it is. This is x of minus t. Okay. So think about your selfie photo. Sometimes it will be in the left alignment, whatever you are taking in the right alignment, right? So imagine the diagram and draw the diagram. Okay, view your diagram first, how it will be in the left hand side, how it will be in the mirror image. Correspondingly draw the diagram in the left hand side. Okay. Then the sixth problem. Sixth problem is x of t minus 2. Okay, so t has been added or subtracted with some values, then it is said to be a time shifting operation. So time shifting operation means just use the value whatever you have within the braces, t minus 2 equal to 0. So t is equal to 2. Time scaling means equate it to 1. Okay, because it is multiplication, you are equating to 1. Here it is addition or subtraction, so equating to 0. So t is equal to 2. Now this value of t, okay, we have to add with each and every instance of t. Okay, so there it is multiplication, so you have multiplied each and every instant. Here it is addition operation. So addition is nothing but we are adding with the minus 2 value. So each and every instance of t we are adding with the value whatever we have obtained. T here it is 2, so 2 we have to add with each and every instance of t. So now it will become 0, 0 plus t is 0 plus 2 will become 2 now. Okay, and then 1 plus 2 will become 3, 2 plus 2 will become 4, 3 plus 2 will become 5. Okay, so just the diagram has been shifted. Okay, so whenever the additional value is some, that is minus 2, if you have subtracting some values, then you will get the right hand sided diagram. Suppose if you have t plus 2, then the diagram you will be having left shifted diagram. Okay, so here we will get the right shifted diagram. So 0 will become 2, 1 will become 3, 2 will become 4, 3 will become 5. Amplitude remains same. So whatever you have there at 0 to 1, now it will comes to 2 to 3. Whatever you have at 1 to 2 will goes to 3 to 4. Similarly 2 to 3 amplitude will go to 4 to 5. So just a shifted signal you will be obtaining. This is x of t minus 2. Okay. So this is your time shifted diagram. it is nothing but right shifted signal. Okay. Suppose if we have plus, then you will be getting left shifted signal. Okay. Thank you. Thanks for watching.